Okay, let's check if the following converges or not by looking at the absolute of an plus 1 over an, if we just say that this is the sum from 1 to infinity of an. So an plus 1, that'd be 2n plus 1, x power n plus 1 over n plus 2 times n plus 1 over 2n xn. So let's see, that would be n plus 1 over n plus 2 times 2x. Now, that's equal to 1 plus 1 over n plus 1 plus 2 over n times 2x. Actually, so I'll just 1 plus 1 over n over 1 plus 2 over n. That's positive, so why am I bothering with the absolute signs? It'll just be 2 times 1 plus 1 over n, 1 plus 2 over n times the absolute of x. Now, as n goes to infinity, this will tend towards 2 absolute x. So it will converge if 2 absolute x is less than 1, which means that x should be between minus a half and a half. We're inconclusive when x is 1. So we have to check what happens when x is 1, because it's possible that there could be equals here, or maybe on one of them. Not when x is 1, sorry, I mean when x is a half, because then we'll get 1 here. So we need to check now. Check when the absolute of x is equal to a half. So far we know it's between minus a half and a half. Let's check the two ends here. So I'll just clear this off. So the case when x is a half, so this sum here, that will be 2 power n, a half power n over n plus 1. I can clean this up a little bit. 1 to infinity. Oh yeah, actually they cancel, don't they? That's nice. So this is looking pretty divergent to me, because what I can do, I could change this into the sum from this n equals 2 to infinity, 1 over n, because the first term here is actually a 2. Yeah, so this will equal minus 1 plus 1 to infinity, 1 over n. And this diverges from the p-series test. Now, what about the case when n is equal to minus a half? I think you'll get this guy here. 1 to infinity. That's a minus. Sorry, when x is minus a half. That's minus a half. So it doesn't quite cancel. You're left with minus 1 power n over n plus 1. So you can do something similar here. This will equal the, let's see, the sum, that's over n. N is starting at 2. Now we just have to be careful, the first term is a negative, so that'd be minus 1 n plus 1. So that's equal to if I started at 1, that'd be minus 1 plus the sum from 1 to infinity minus 1 n plus 1 over n. The first term is 1. Okay, so that would equal minus 1 plus minus 1 minus the sum from 1 to infinity. So if I flip the signs around, I could change that to minus 1 power n over n. So this one here is an example of a divergent series, and this one here I think is called the harmonic series or the alternating series or something like this. And this one actually converges. Let me just double check the name. I'm pretty sure it's called the harmonic series. Yeah, so I need to be a little bit more careful. It's the alternating harmonic series. And I think the last time something like this came up, I called it the harmonic series, where I should have called it the alternating harmonic series. So it converges. It's the alternating harmonic series. It converges. So therefore, this will converge if x is between minus a half and a half. But in the case of the minus a half, we could get it to converge. In the case of the half, it diverges, so it's actually equal on the left side here.